It is important to remember that physical changes have the same molecules before and after. In a physical change, there are three states, so solid, liquid, and gas, and this can happen through mechanical or thermal energy. And the motion and arrangement of molecules determine the state. So when the molecules are tightly packed together and vibrating, as I'm modeling here, they're a solid. As they're just a bit further apart and sliding past each other, they're liquid. And if they're further apart and bouncing off each other, they're a gas. So when we did the butter experiment, there was the thermal energy from my hand, which had more than the butter. So we went from one unit of thermal energy to another unit of thermal energy. And when that occurred, the heat from my hand gave the molecules more energy to move faster. So they went from that kind of vibrating to sliding past each other. And the faster moving molecules hit against other molecules, and the molecules spread further apart, and a new type of arrangement and motion was determined. And now there's a new substance, and it's a liquid. So to demonstrate here, when they're close together and just like a solid, it'll be 1.3, and even when they're a liquid and further apart, they have the same mass. So the mass is the same in the beginning and the end because atoms are forever.
There you go.
A chemical change is a change that occurs with chemical energy involved and a new substance is created. So with the mustard and the OxyClean, here we have 1 unit of chemical energy for mustard and 1 unit of chemical energy for OxyClean. And so when there's a chemical change, the atoms in the mustard are attracted to the atoms in the OxyClean, and the mustard's pull to the OxyClean is greater than the pull within the original molecules. So then the atoms that are attracted move together to form new groups, which is what we have over here. And then over here there's the new substance. Old molecules are destroyed, new ones are created, and we still have the same amount of chemical energy because it does not change. There will always be the same amount of chemical energy at the beginning and the end, depending also if there is another form of energy. There may also, if that could change. So then we have the masses, which will equal to be the same. So when we have the chemical, or the molecules of the mustard with the molecules of the OxyClean, it is 2.5 grams. We have the molecules of the new substance. It is again 2.5 grams. So no units are created or destroyed,